today about sustainable development goals. We are talking about emerging technologies that have grown too fast and are ready to be deployed, where we are using them in our manufacturing and industry with Industry 4.0. We have hundreds, literally hundreds of think tanks, agencies, consulting firms that have brought in their own ideas, and then they've put it on board and they said, look, we have these solutions, why can't we use it? So somewhere there was a thought that we should look. If you look at some of the look, if this slide basically gives you an idea how the world is changed today. We have a global IT scenario that is changing. We are forced to kind of today align to national and international agendas, most countries. And then are our skills ready? Do governments have the right kind of skills to kind of provide these services? And then we've also, to a certain extent, established good governance. But are we delivering reliable services? And India is, as a country, has started, working with a number of countries across the world. We are talking about North-South dialogue. We're talking about Global South. So with these new agendas, with these new targets, for example, one of the targets in SDGs is to simply eliminate poverty of all people. If you have a goal like this, is it simple? Can we actually achieve this? These were some of the questions probably that were asked, and then Viksit Bharat, it's saying that we are going to become, we are at least trying to aim to get to 30 trillion economy. Is this possible by 2047? So if you really want to achieve these goals, then we must disrupt the way we are working. We must change the way we are thinking, and then yes, we have a certain expertise in using technology, but is that enough? Is that sufficient? So that's where with integrity, with integration, with interoperability and new technologies coming in, we've moved on to something called DPI. Next slide. Next slide. Can I have the next slide? Okay, let me share my screen. Yeah, can you hear me? Am I audible again? Please, I have to ask this question again.
Yes, Sachit, you are audible.
Yeah. So then we moved on to the next level, and then we started asking the questions. I've put down the questions on the right side. Do we have the needed technology and the required e-governance and technology maturity? Do we have the competency to design systems that can actually do high volumes at low cost? Do we have the legal and policy framework that's actually creating an enabling environment to something like a DPI to be implemented? Or let me simply say digital transformation as it is. Is our focus only on service delivery? Are we also inclusive? Are we creating transparent systems? Are our systems accountable? And can we achieve these targets? With these questions, I think DPI came into picture. Just putting in perspective, what is public infrastructure? Public infrastructure, any road or a highway or a park is a public infrastructure, but it's physical infrastructure. But can we create something like that in a digital sphere? So if we create an infrastructure that is public in the digital sphere, anybody can come and use it. That's the idea behind digital public infrastructure. So if you have a highway, people can actually, run their transport systems. People can run their vehicles on it, or people can create services associated with that highway. People can open hotels, people can open dhabas, people can connect to different markets, people can access different services because there is a highway. What if there was no highway? Then probably, this entire thing would be more difficult. But creating such public infrastructure makes a lot of sense. That was the idea. So to simply quote some of the founders behind this, let's say, to quote Mr. Pramod Verma, He says DPI is a thinking and it's not some technology. And then Nandan Nilekani ji, he says DPI is a technology that is used for the masses, that can benefit the masses. Now, saying this, so what exactly is this DPI? So we are trying to create a digital infrastructure, which is simple, which is kind of let us say minimalistic, which can actually help other IT systems to kind of operate on that infrastructure. So it could be a platform where certain services can actually be used, but for that there are certain preconditions probably that are required. And three key preconditions or pillars of DPI are the digital identity, the first one. The second one is a payments gateway where certain transactions can actually take place. And the third one happens to be exchange of data, or data platforms which can actually talk to each other. Okay, so I've also given two definitions just to give you an idea what exactly DPI is. What are the tenets of DPI? First, it should be inclusive. So anybody can actually come and use this particular infrastructure. If that is not there, then DPI loses its relevance. And it's foundational. Today, if you're saying, what are those foundational aspects? As I just said, the three pillars: the digital ID, the digital payments, and the data exchange between different systems. It should be interoperable. Should be interoperable where different technologies can actually speak to each other. It should be technology neutral. And then should be publicly accountable. It should be safe, secure, trusted, and transparent. So would you actually go and buy or for example, if you simply download an app from Google Play Store and it's riddled with different viruses, or it's actually not working, or it has a lot of bugs which is actually creating a lot of issue, then would you actually go back and download some kind of an app that way? No, you would not. You would want to kind of simply grab on or hold on to a technology that is free from all these. So it's free from any security issues. It's free from privacy. It takes care of privacy. It's free from any kind of risks. That's the kind of system that is. So basically, when you're designing infrastructure or goods around it, it must be accountable. Then privacy by design is another important thing, because a lot of data is being shared, especially in government when we are trying to build services in health, education. Personal data is being shared, so the data must be protected and scalable. Why is scalable so important? If you see in the first slide, we were talking about large, goals. We have set targets which are not easily achievable. If you really want to achieve those goals within a set period of time, then we should be able to scale up technology systems at a pace that it can touch large scale masses in a very short period of time. So if you look at UPI as a beautiful example, within 5 years it was able to touch about 800 million, because people trusted that system. So with these tenets, let's move on to the next slide. So once you have that infrastructure, then you can create goods. What are these goods? What are these digital public goods? These digital public goods actually operate on that particular digital infrastructure and that public infrastructure, because public infrastructure is free. It's there, lying there. It's like a highway. It's available for anybody to go and actually use it. And for that, you have a digital ID today, which is ready. So, for example, if a health, let's say, agriculture farmers registers. So it's a public infrastructure. Once you identify these registers and they're available, you can create apps or goods which can actually talk to that particular register and bring out that particular data and start delivering services directly. You don't have to recreate. So you are creating an infrastructure and putting in place, and then new goods can actually be developed. What is a good? Any kind of an open source software, any open data, any open AI models, any open standards, any open content, okay, that adhere to privacy, security, and then operate under specific laws. We can call any of these as digital public goods. They are for the benefit of the community. Okay, they follow certain standards and practices, and it can be developed with the help of public and private agencies. They should be made freely available, and then they adhere to certain policy and regulatory environment. And another important aspect of DPGs is that nobody can claim that it's theirs. Anybody is in a position to actually use it. So, with that being said, today we can see the kind of impact that DPI has created. UPI, as I said, in the last 6 years, it's grown at a CAGR of 162%. 117 billion transactions today are actually happening on UPI, and it's a great success story that India has brought on board. If you look at the digital profile of India, it's ripe for creating this kind of technology to come in. You have 1 billion smartphone users, you have more than 1 billion mobile users, you have active internet users. There's a huge population, both rural and in the urban areas, which are using systems and who are using applications in Indic languages. It's also available in local languages. So with that being said, India has spearheaded the entire DPI for the Global South recently after the presidency of India in G20. They've been able to take up certain steps to ensure that our best practices like UPI, Aadhaar, CoWIN, your ONDC or Diksha, some of these, Ayushman Bharat, some of these can actually be replicated elsewhere in different countries, and we can actually support them. More than 50 countries have now come together as part of the G20 task force. And then the India stack, which is your Aadhaar, UPI, and digital exchange of data, has come up. The DEPA architecture, as they call it, is also being provided to different countries. Government of India has created the Social Impact Fund. This fund brings together about 50 countries which are collaborating to see some of these DPIs implemented in their countries. And India is one of the first countries to commit about $25 million to this particular Social Impact Fund. We have other countries coming on board. And then UN as well as India, they have created something called the Global DPI Repository. Digital Public Infrastructure Repository is there for the taking. So UN also has created a similar one where you can actually go and scout for digital public goods and actually take it from them. There are about 54 DPIs from 16 countries that are provided in this repository. And then DPI platforms like CoWIN, Ayushman Bharat, they're all making a big difference. And Government of India has also created something called ICDIA, International Center for DPI Innovation and Advancements, which is actually collating all this information, bringing together, connecting different stakeholders, innovators, startups, to kind of work together, form networks, form, as I say, groups which can actually help, further implementation of DPGs and DPI, or further this entire idea. So it's the right moment where Government of India took the step that we must think of energy sector as well. So I would ask my colleague Sudha to take over and then also share his inputs on the India energy stack and how the entire thought process and what exactly is happening there. Sudha?
Yeah, sure, Satyajit. Thank you so much. Should I share or you will be sharing?
No, I'll scroll it for you.
Okay. Thank you so much, Satyajit. And thank you for the presentation on the DPI aspects. India is growing across on the DPI segment. So currently, why India energy stack? As we understand that India has already committed for net zero till 2070. So there are various targets that they have taken. I have mentioned some of the targets for 2030, like 50% of energy requirement from our resources, reaching a non-fossil fuel capacity of 500 gigawatt, reduce carbon emission by 1 billion tons, and reduce carbon intensity by 45%. So if you see, to reach those targets, there are various initiatives that has been undertaken. like battery storage, green hydrogen, electric vehicle, implementation of smart meters, development of carbon market and all. So on those aspects, if you understand, like a lot of these solutions or initiatives that you have undertaken, like electric vehicle, rooftop solar under PM Surya Ghar, or even green hydrogen or modular aspects of green hydrogen, distributed storage, they're connecting on the distribution of the distribution LV grid, what we say. Now, if you think that there are a lot of sources, please move to the earlier slide. Thank you. So, if you understand that there are, if these initiatives or these resources, which are considered, you can consider as intermittent generation on the rooftop solar and others, and flexible demand resources like electric vehicles, like V2G, even on green hydrogen case, there is a you can produce power from there, and there is the grid integration aspects, which have significant impact on the distribution grid also. Right. So various distribution utilities are currently looking into this, how to optimize the grid integration of those flexible demand resources as well as the intermittent generation resources. And there are a lot of innovative with technology, a lot of innovative models have come up on the demand response side, on the peer-to-peer trading of electricity and virtual power plants and all those aspects. So if you see, so there is a huge requirement of data management because a lot of data will be generated, and implementation of these innovative sources. If we're doing if you're implementing this on the grid, and how to manage the grid to ensure its reliability and flexibility. So IES as a enablers is a standardized, you can say, is the open source digital infrastructure, which normally will provide you with the unique identifiers for assets, consumers. So if you see the IES architecture, there is a as described as published by the Ministry of Power. If you can understand that there are unique registries for assets, there are unique registries for consumers, there are unique registries for utilities, as well as there will be historical data and all, which will be the, you can say, the data store. It will act as a data store, and that energy IS will, the another aspects of IS will be the data access for the application layer with the utility intelligence platform. I'll come into the next slide. So the next slide, please. So here, this is the IS India Energy Stack and the UIP, the Utility Intelligence Platform. So what are the IS enablers on that? The unique digital IDs and creation of digital registries, open APIs for system integration and interoperability, plug and play architecture through standardized protocol for data exchange, and ecosystem innovation through open data and unlocking data access. Now, these questions, if you see, these enablers, if you see on that, so there will be need for a consumer registry, there will be need for a asset registry, there will be need for open APIs because there are legacy systems or the homegrown systems that are utilized by utilities, which are difficult to integrate sometimes with the CORD system. Even the plug and play architecture through standardized protocol, all have, currently if you see the utilities, all have the data in silos, right? If you're putting up AMI, the data is there, but we are not integrating across the utility itself. So how we can see, how we can foresee that in future it will be integrated across the utilities, right? So this is one of the areas, because the ecosystem innovation will come through open data and unlocking data access for other utilities also for the utility. Suppose taking a case of peer-to-peer trading of electricity or rooftop solar using blockchain. In Delhi itself, if a customer sitting at a BSS and if a customer sitting as a Tata Port Delhi, how they will trade the electricity, how that will be managed and everything, that is still not being formalized because the utility integration is not there. Even in some of the utilities, even Tata and BSS and other very technology advanced utilities, even some of the utilities don't have that data itself to move ahead, right? So that's a big question. Are utilities well prepared? I'll come to the next slide on that. But before that, if you see the utility intelligence platform, because IES is giving you one of the data store with the registries of all that, even the historical data from the discoms. Then there is a data access layer is there, where there will be open APIs and standardized protocol for data exchange. Then there will come the utility intelligence platform. What will happen in the utility intelligence platform? Because they will in the utility intelligence platform, the AI engine will be run on those data which have been sent from the IES, and there will be a role-based data access management in the IES. So UIP will run based on the predictive modeling and all. They will generate various using analytics and AI and all. So they will generate various data which will help us on the real-time decision making and all, and it will help us to develop new market instruments like peer-to-peer trading, virtual power plant, and local energy market integration of decentralized and centralized unified payment system for energy. Now, what do you call this local energy market with vehicle to grid, with rooftop solar injecting power into the grid, with distributed storage? The distribution grid itself will act as a market in near future, right? Because a lot of electricity will be generated within the distribution system. Now, within that distribution system, how it can be integrated with the centralized market so that they can help the balancing the grid using the frequency balancing and other things, ancillary services. So there will be a requirement for data. Now, the question was there, are Indian utilities ready? Which I asked in the previous slide. Because when there is a requirement for all this data and how the utilities are really smart, because on the network there is a smart grid implementation is required, then system integration across the utility or the utility-wide system integration, like ERP, GIS, and mobile workforce management system integration for asset management, AMI and consumer information system for customer centricity, right? Then there are implementation of smart grid technology and IoTs, devices, sensors, DSS, or we call it substation automation, grid automation. Are the utilities are doing all these things? Because without having digitally transformed, these utilities cannot provide the data that IES is actually required, right? And they need to be smart in their at least the business processes and how they're carrying out. Because the data is the ultimate fuel for this. Even on the customer centricity, on the improved grid reliability system control through ADMS, DERMS implementation for DR integration, robustness on cybersecurity side, security operations center, SOC, NOC, and all. And the major part will be the policy agility and the regulatory alignment for technology adoption and pilots. Because we have seen that in many cases, it is new technology adoption, there is no regulatory alignment, or there is a delay in getting the regulatory alignment for the sandbox or the pilots and all. And there is a need for institutional strengthening on the digitalization aspects. So one of the aspects that is I'll say the key driver for this IES, that every utility, or at least most of the utilities, should have their digital transformation strategy and implementation plan that should align with the vision, and the organizational structuring of those utilities should also align with the vision and this digital transformation strategy. And there need to be a capacity building and institutional strengthening for digitally skilled workforce. And I think that is already being planned to be carried out in parallel with the IES implementation. So when we are thinking of these areas on digitally transforming utilities and all, one question arises: will DSO framework become more relevant? Because with more data coming and the need for managing the distribution grid, where the most of the flexible demand resources and intermittent renewable resources will be connected. How the distribution utility framework need to be evolved so that it can ensure grid reliability, flexibility on the other side, and also focus on the efficiency improvement and revenue enhancement. So with that open question, DSO framework will be more relevant in this case. I will end my session, and with this, I will request Mr. Arindam Ghosh, who is the partner Power Sector Advisory with Ange Anderson, to take over and moderate the session. Thank you, everyone.
Thank you, Sridhar. And so I would like to request Mr. Alok Kumar sir, Mr. P.K. Agarwal sir, and Sainath to join the conversation. So we have a very, very good panel. So
yes, hello Arindam, nice to join. Yes. And it's a good. Am I audible clearly?
Yes, we can hear you. Yes. Okay. It's unfortunate that Mr. Pujari could not join us, but we have also had a little bit of a technical glitch in the beginning. Apologies, everyone, that because of a technical glitch, we started a little late. And so, I mean, we have a very, very good panel to work with. I mean, I was obviously feeling a little nervous about talking about this India energy stack, because I don't know anything about. People are talking about this, but so we wanted to hear from the people who are part of the committee who has been formed. So both Alok Kumar sir and Agarwal sir are part of this committee, and Sainath joins from AWS. AWS is also part of the team. So we'd like to hear from them. So let me just directly get into the question answer session. So, Alok Kumar sir, so maybe the first question for you, that we're thinking that since you also represent the AI DA right now, so you have a very different kind of a role to play. So what do you think that primary the operational or the financial challenges discoms could face adopting the India energy stack, and what do you see the prerequisites for the discoms to implement this IES?
Thank you, Arindam, for having me on this panel. It is my pleasure and privilege to be talking in this webinar. Say, we had very good presentations and they have set the right context. But you had brought this DISCOM perspective, and that is very critical because other examples of UPI, DPI, they are relevant, but they don't apply completely to the electricity sector, which we are trying to handle. Because this is a system which is grid driven, network driven, which is regulated and which is concurrent in our constitutional scheme of things. Other things are financial markets, which are completely, say, in the union list. Simple transactions. Banks had a lot of IT infrastructure on which UPI was built. You are entering into an area which is very critical for India's growth, India's development, but has its own legacy problems and the given status. So, first and foremost challenge will be, in my mind, my view will be the capability in the distribution companies. Some of the companies like working in Delhi or Mumbai and Bangalore, they don't represent typical distribution companies. So if you think of distribution companies which are in other states, smaller states, hilly states, the level of understanding and level of capacity they have, it is a Herculean task to build capacity for them. First, to understand the implication and urgency of this digitalization and India energy stack. Then they should be capable of preparing proposals for approval by the regulatory commissions. And then once approved, how to procure and how to maintain and run it and empower the consumers. So the challenges which lie are mostly in the capacity building side on both the distribution utilities and the regulatory commissions. We are seeing an example of smart metering, which everybody now understands and agrees that smart metering is a must for if you want to have any meaningful DER integration, any demand response, load research, anything. But still, in large number of SCRCs, they are still in doubt whether to allow its cost in the ARR or not. When you're talking of digitalization and many advanced solutions, so the whole regulatory philosophy to take up the cost benefit analysis will be very crucial for this. I'll say before that stage also, the what to procure and when to procure is also an important decision in the distribution companies. I will give you my example. When I was chairman UPPCL, one vendor approached my minister. He says, this is a software very forward looking. This costs 65 crore rupees. You can purchase it. It's a single source basis. We found that many of its modules and components were not relevant for next 5-6 years. So different type of vendors are going to utilities, offering various solutions and all. So one starting point should be, which IAS has done, which is a good beginning, are the national template and national guidelines for the distribution companies. So that this will be a market transformation for even the software developers and the vendors. Once such national guidelines and national template is available, the distribution companies can assess their requirement and their trajectory. They can prepare their proposals, go to regulatory commission. And if we empower our regulatory commissions to undertake the cost benefit analysis, which is a must because the cost will go to ratepayers. So once it is approved, then execution stage, I will again say, there has to be a national resource center to handhold the utilities for implementing the same and for also troubleshooting and helping them to resolve problems. So All India Discom Association has proposed one resource and knowledge center at national level. Apart from other things, which we also have a vision of having a pool of resource and trained manpower versus discoms in this endeavor. So I will stop at this point. Maybe if there are further questions, I will come back. Yes, Arindam.
Thank you so much, Alikumar sir, that because you brought the DISCOM perspective. And since the panel we have distributed, we have P.K. Agarwal sir. So he brings because he's a power system specialist, and that's what we know him. So, sir, can I go to the next question for you? That since IES, we are talking about real-time grid management. So how do you see IES will come in as a part of real-time grid management? And one of the real challenge which we have been facing, all of us know, that the forecasting. So do you think that IES will bring the forecasting capabilities to handle the intermittency and the other renewable resources? So that's the main challenge, which are also the variable demand patterns. So what's your view on that? So
thanks, Arindam. Let me thank you for Namgia for calling me for this wonderful discussions and wonderful speakers. So first thing, this IES will be solving a very, very long problem, providing a unified ID or unique identifier for each asset. So when I moved from northern region to national load dispatch center in 2012, I saw that because there are about 40 control centers in India. So and the data from each control center, each of that 40 control center has to come to national load dispatch center. And data and this national load dispatch center integrate all the data. So I saw even data and model from the same vendor is not integrating in that SCADA at NLDC. So what for all the data, we require the data and the model. So data and model is available only from the source where it might be a power plant, it may be a substation. So data is the actual real-time data, and model is how that element is connected and what are the parameters of that element. So ideally, that if the source system has entered that model in the SCADA system, ideally that should percolate to the NLDC. So starting if the DSO is there, so the DSO starting to sub-LDC, SLDC, region, and then NLDC. But because of this unique identifier was not there. So at substation, it might be calling with a different name in southern region. It might be calling with a different name in northern region. So we try to solve this problem with the common information model. So in 2014, when we were upgrading the SCADA system, we asked our technical specification that their system should be SIM compliant. And so if SIM compliant means they can export the model from one control center and then import the same model in other control center. So this was again not happening because different identifier, and then SIM was treating them different stations. So it was not. Then I tried to create a master data. So it is a unique identifier, but I was naming it as master data because I was not expert in IT system. So, but I tried that I could not. Let me tell that I could not convince my colleagues that this is required. So this will be solving a very long-standing problem, and I was working with this since last 10 years. Now again this in LITD 10, I am a member of that, and I started uniform naming convention panel. So what will happen now? Now when we have a different creating model at every level and mapping the data at every level. So there is inconsistency of data at different control center, and there is no single source of truth of the data. So it again creates a problem of in real-time operation. Not a big problem, but the problem that model is not predicting that system state is correctly. So that might be predicting something else in SLDC, and that might be predicting something else at NLDC. So with the IES, when we will have a unique identifier, so we will be able to implement a common information model in the energy system, and there will be a single model India-wide. Being a single model India-wide means you have more accurate forecasting, more accurate system study. And again, with the proliferation of DERs, the granularity is still increasing. So when there's so much granular data is there, and that DSO has to be there with for managing this DERs, but this because they are connected to grid, so this main transmission grid will also be affected with that. So when this they will have the unique ID, so then system operator will have the visibility of that all DERs, and when the DERs are aggregated, they provide very good service to system operator for demand responding and but for generating more energy at the time of peak hours. And again, forecasting also data intensive application, and many different type of data is required. We require data from the last 10 years. We require the real time data changing in weather conditions. So all these are required, and which will be available with the digital infrastructure, GPI. So that forecasting will also be that it will improve, and it will be is better or accurate forecasting means accurate renewable energy integration. So with this, I will stop here, and so this will solve very big problem for me at least. Thank you.
Yeah, thank you, Honorable Sir, because you are a practitioner. So you are bringing the point of, as a practitioner, what are the challenges you had faced, and now with this, you hope that this kind of challenges could be resolved within IES. Now I'll come to Sai. So you bring in a very different perspective here because you come from the solution provider. So the first question I'll ask you, Sai, since you have seen globally, right, as AWS, as Amazon, so you see that how the other parts of the world also operate. So what are the best practices from the global cloud platform and can inform the standardization of the APIs and the interoperability protocol? Because that's what Alok Kumar sir mentioned, that earlier the vendors, the meter vendors will not talk to the others, so we'll have separate HEA, separate MDMA, so those kind of things. So interoperability is given. So we are all used to interoperability. So how do you see this? Because we would like to hear from you about the global perspective, which is the best practices. How can we bring in here?
Okay, sure. Yeah. And first of all, thank you for inviting me for this one, and good evening, everyone. I mean, before I move to the tech part, a couple of points that I want to add here. One is, one very important point that PK Agarwal sir also mentioned just now in terms of naming convention or nomenclature that we talk about, right? I mean, even from Discom's perspective, if we look at a consumer as an identity. So every utility has their own way of naming that. So some say it could be a circle plus division plus section plus a running serial. Some would say it would be probably a numeric, right? So there's one level of standardization which needs to come across, and consumer as an identity is just an example. And we are an asset intensive industry, right? So even a meter, even a transformer, even a feeder, so it has to spread across. So and once we do that standardization at that level, it would obviously be inherited in the API layers that we are talking about, probably in IES. So that is one important point. Another point that I want to bring about is there are quite a few standards that we have been adopting so far, right? And it could be, say, IEC 61968 or 15959 or OCPP. So quite a few of them are there. So when we move towards this, what is important is in IES, it should not be drastically different from what we already have. Because adoption of these by solution providers is something which is important. So if there is no adoption, then obviously there is no scaling on this. So that is one important point that we need to look at, that there has to be a balance between what we are already implementing and the progress of implementing, or smart metering, for example, right? So there is a large scale rollout probably started 4 years, 5 years back. There are quite a few million meters which are already there on the ground, and we also have a long runway. So how do we move in a similar direction and not a tangential direction is an important point that we need to look at and align with the existing standards that we already have. Another one is, again, like I mentioned, we are a asset intensive industry. When I say we, the power industry, right? So we have different standards for each. For, say, EV charging, it's a different standard. For smart metering, it's a different standard. For OT, it's a different standard. For wind and solar, it's a different standard. So what we should look at is how can we, bring some standardization in these aspects as well. At the same time, maintaining that balance between functional requirements versus simplification. So that's an important point that we should also look at when we're talking about, how we can do this. And from cloud perspective, there are quite a few open protocol standards which are supported by cloud, which could be, say for IoT integration, it could be MQTT, or for, say, machine to machine integration, it could be around REST or message queues or publish subscribe. So these could be some of the standards that we should consider as part of IES, so that when the actual implementation of the stack happens, the development time by the solution providers or the utilities is reduced, so that they can leverage what is being provided from cloud, and the development time is reduced by virtue of leveraging these services. So I'll stop there.
Okay, thanks, Sai. So I think, yeah, this is very good that what you mentioned about that. I'll sum up in my concluding comments. Yeah. Alok Kumar sir, I'm just coming to you for the next question. That, I mean, since again you are wearing the DISCOM hat, so my questions too will be related to DISCOM. So how do you see that? Sir, you there, right? Your video is just off.
Please continue. Please continue. I'm
Yeah.
there.
Okay. Yeah, sure. Okay. So how do you see that this energy stack can enable the DISCOMs to evolve from a traditional utility model to a platform-based energy service provider? Because we have seen this energy service providing in Europe, particularly in UK, there's a lot of energy. The DISCOMs are becoming an energy service provider. In India also, I've spoken to a few private DISCOMs. They also wanted to be a energy service provider. So because why they see that this could be a digital platform to facilitate everything, that the demand response, and particularly we're talking about the AI and ML kind of thing. So maybe using blockchain. So I wanted to hear from you, sir, that how do you see that IES can enable DISCOMs to move from this traditional?
IES is one of the building block in the whole scheme of things. So somebody has posed a question in the chat box also, because I will have to leave after this, so let me also answer this. It says that is the national guideline framework for DISCOM that you mentioned is already in place, or is it being envisioned under IES? I'll say IES is one part of the whole scheme of things. IES is, as I understand, is one standard template and maybe one application of utility intelligence platform, but it will have several applications. And we should not say affect the innovation. While we standardize, innovation should be fostered. Transforming the distribution companies to energy serving utilities, energy serving digital utilities, will have to have 2-3 components. First is, I'll say, is the technology part. The IAS is one part, then how to procure applications, then capacity building to adopt those technologies is one part. Second important part in the whole scheme of things is the liberalization of the electricity market, not at wholesale market I'm talking of. I'm talking of the retail market, because most of the IAS is not for wholesale market, is of course is there and it will develop. We are different jurisdictions, different type of regulations. We have a burden of the cross subsidies, because like cross subsidy is one thing which is a main obstacle. Even if you have a wonderful world-class technology stack and all, you will not see the consumer empowerment and P2B trading across states unless until your regulations are harmonized and they become liberal and you address the problem of cross subsidies. So reaching to that stage will need work in different domains. So that we should be clear that. And then the whole issue of viability of DISCOM, if you want something, you will depend on utilities for the payments and all, payment of charges, settlements and all. So it needs a very comprehensive thinking in addition to the IAS and digital application in terms of the regulatory reform and in terms of the utilities become agile and financially viable. So about this national guidelines, I'll say they are in some fragments in RDSS guidelines, some fragments like yesterday ministry has issued a survey form to the DISCOMs that these are the 5 principles you have to do, and what is your preparedness, where do you stand for implementing these five tasks, like the detection of abnormalities for theft detection, predictive analysis for load research and all. So there are so many things. So I think it's a long journey to go, but it's a good beginning. We should have begun even earlier. So my take will be this needs very comprehensive work, consistent and continuous mission approach, and working in various spheres required. So I think Arindam, I am clear, I suppose, about what thing you are trying to ask.
No, thank you very much, sir. So, and thanks for answering the questions one of the audience also raised at the same time.
Arindam, maybe I will have to leave around 5-10 minutes. Maybe I got some visitors. So you please continue. If there anything within the next 10-15 minutes, I will be able to answer. Otherwise, then.
Okay.
I will
so maybe shall I have one more question for you. So maybe with permission from Agarwal sir and Sainath, can I ask that question to Alakumar sir before? Yeah. So one of the question which I had for you, that how do you see that IAS can facilitate a seamless integration of the local energy market? Like all of you talked about the DER integration, even Shuddha, when his presentation talked about vehicle to grid, and we also now seeing a lot of distributed storage. So with centralized wholesale market, and while also we need to maintain the grid stability as well as the fair price discovery. So how do you see that can IAS facilitate that?
IAS will have a crucial role. Very crude and simple example is like internet protocols. You are able to send files, talk to different computers across the world, and then you see in so many domains. So IAS is one necessary foundation that different systems and different smart assets will be able to talk to each other seamlessly, and that is the necessary, not sufficient condition for development of the local energy market, I'll say. So it is a must. We must do it at the earliest so that we are able to address some legacy problem, but we don't create more legacy problems in future. If we start now, it's a relatively quite a clean slate for India, because smart meters, we are still around 3.5 crore. We have to go to say 10, 15, 20 crore. So it's the right time to do it so that we are able to accommodate the legacy things, what Mr. Sainath was saying. But if we do it 5 years later, it will be still more difficult to do, because by the time you have done this, we have seen across the world. So IAS and accompanied applications will be very crucial. They are must, but they are not sufficient. So I will answer in that fashion, Arindam.
Thank you so much, sir. So Agarwal sir, so the next question for you. since you also had the hat of the CISO, so everyone talks about the cyber security these days. Like when we talked about, even when we had the Aadhaar, so people talked about the security protocol, and a lot of those discussions was happening. So from that point of view, so what are the cybersecurity infrastructure standards are essential to protect IES from a grid level threats? So, and also we need to maintain the operational efficiency as well. So that's where I think you are the best person to answer this question.
Okay. So first, DPI will be a layer on the grid infrastructure. It will not be integrated with the grid infrastructure. It will be layer, and all the operational and settlement data or metering data or that contract data will be shared with this DPI. No real-time data will be shared. It is not required actually real-time data by the other player other than player who are involved in the grid operation. So as it is a DPI is a IT systems. It is a IT application or IT infrastructure. So whatever protocols and standards are being used for IT system, it should be used there only. And when we are sharing data from SCADA system to DPI, so there is a well-established system. It is not directly connected from a SCADA to the other things, other where we are sharing the data. We are not directly connecting that SCADA system to share that data with a single link. What we are doing, we are getting that data first in a staging server, or we call it a replica server. So that whatever data is shared, it is deposited in a replica server, and it is only one single one-sided traffic. Only the traffic from SCADA to outside. So that replica server is always located in DMZ. So all the data shared from that DMZ as a public subscriber model. Again in the DPI, all the data will be shared through API. I don't think that there will be direct connection between control center and DPI. It will be through API, and RESTful API is very old thing and very established thing. So all the cyber security which are being used for the API and the RESTful or IT system, I think that standards are sufficient and that standard should be used.
Okay. No, thank you, sir. So that's because I feel that you have seen this, how the cyber threats had come in the system, and so I mean, so no need to worry. So you give us that kind of a comfort that we don't need to worry about that when we have the IES thing. So, Sai, coming to you on the infrastructure architecture principle. So what should guide the IES development to handle the India's scale of diversity and energy stakeholders? Because India, when we talk about India, everything is large. It has to be scalable. So since you bring in that kind of providing the infrastructure capability, so what do we need to consider about that?
Okay. So, I mean, to give, I mean, you rightly said, right? I mean, India is about scale. And if we have to take some numbers around it, again, going back to my initial point, if we have to look at consumer as an identity, it could be around 300 million, at least the number of unique identities, right? And if we multiply it with, say, readings or bills or payment transactions, it runs into a billion. So that is the scale that we are talking about. And similarly, in another example that Sudha also mentioned, right, about PM Suryagar. So that also is a target of, say, 1 crore rooftop solar. And which again, it's not just about monitoring, but how do we integrate into the larger grid? All this leads to, how do we handle the scale at which we operate, or the IES is, designed to operate along with the utility systems which are there. And a few important points that I want to mention is one, this scale aspect is something which needs to be considered by design. I mean, like the way we talk about security by design, a scale aspect is something which needs to be considered by design. And especially in terms of the fluctuating scale that we always have, because we can't predict, when would there be a flood of events, flood of recharges or flood of, say, signals coming from, say, fault passage indicators. So we don't have a view, right? So that systems or the framework should be adaptable to that scale or the fluctuating scale that we are talking about. And when we talk from some of the principles perspective, I would like to refer to what in AWS we call it as well architected framework, which talks about what could be the best practices that need to be considered or that should be considered when we are building for, solutions on cloud. So, and some of the aspects which are talked about is security, obviously in terms of, say, data protection, infra protection and all. And how do we handle reliability? And especially when we're talking about this scale of systems or a framework, reliability is an important aspect. So you can't afford to have failures in the system, right? I mean, for example, it could be a payment transaction, it could be a a control action which is happening probably onto the field. So reliability is an important aspect, especially at this scale, because a little disruption could lead to a good amount of impact, right? Third point is around scale, the main question that you mentioned. So scale is, the traditional way of, how do we add more, say, servers or storage to scale and handle that load. So that may not really work when we talk about this large volume. So that is where some of the points like how we could auto scale to handle those transactions at the same time, considering the cost aspects, which again, Alok sir rightly pointed out that it's not that, you set up a huge infrastructure and keep paying for it when we don't know how the scale would actually be there. So that is another important point that we should consider when we're talking about scale. And more importantly, going back to my initial point, this is something that we need to consider from the start, from the framework standpoint, from the utility systems standpoint, and bringing these two together to handle those, integration points between the systems. So that's where I think scale plays an important role that needs to be considered from day one. And needless to mention, scale testing. That's an important point that needs to be done. Everything may not be considered on day one, or we may not be able to assume everything on day one that the system would work fine if I architect it this way. So before we actually bring it into live production, as we call it in IT terms, that scale testing is something which is to be done.
Thank you. Sai answered it very nicely. So this actually leads to my question to Agarwal sir when you talked about. So, sir, I mean, how do you think that IES can ensure this data exchange protocols between these grid operation centers, utilities, now also the market participants? We are opening up this market. So this is, I mean, probably you can answer. I mean, how do you think that the secure data exchange can happen through IES between these 3-4 players?
Okay. So, Arindam, there are some questions on the chat box. Should we take that question now, or we will take in a separate question answer session?
Maybe
I
we
think
can.
one very relevant question is this.
Yeah, sure, please.
Yeah,
Please.
See, IS moving as a transmission as a service. Do you see this IS moving as a transmission service? Transmission as a service. So transmission already is service because it is a shared infrastructure, and then it is being provided as a service. And open access and open access or GNA regulations, they already have the regulation which provide transmission as a service. And we have a very big application, National Open Access Registry, NOAR, where any seller can access, or any wire can access that and have the transmission access so we can take as a service. But again, as Sainath was telling, that it will depend upon how this infrastructure takes shapes. Then because when we there are many players for the DPI in IEC. not as opposed to the UPI or NPCI, where only the banks and consumers are players. Here they are different players, market players, grid operation, and many things. So we don't know what shape it will take, and there may be a shape in the future when NOAR and IES also merges. So currently, we cannot take, but transmission is still as a service is being given to them. So coming to this IES protocols, data exchange protocols. So data exchange between control centers, they are well-established systems, ICCP and IEC standards, and those are the real-time data, very time-critical data, and they don't require any new protocol. So the same protocol will be used. So IES will not affect data exchange between control centers. It will only enable the data, operational data, and post dispatch data. Well, if you see the grid operation, there are three distinct activities: post operation, pre-operation, or pre-dispatch, which is generally a planning activity. So if we see the day-ahead schedule, that is the operational plan, dispatch, and then post-dispatch, which is settlement activity. So dispatch and real time will not be affected by REC, IES, other than providing a unique ID, which is also one-time activity, because unique ID will not be changing once that element is indicated in the grid system. So different protocols used for pre-dispatch or post-dispatch activity, that is being already shared, that data is being already shared, and that I mentioned before also, it will be shared through the API. It will not be shared directly one-to-one connection. So I don't think any new protocol will be there. It will be only some commercial transaction might have some different protocol like NPCI and UPI. Yes.
Thank you. No, thank you so much, sir. So that's really, and the transmission as a service is a very relevant question someone asked, and you answered it quite rightly. And Sai, coming back to my last question for you, and so this is where so how can utilities leverage AWS and the public sector solution to accelerate the digital transformation and the journey while implementing IES? So this is very specific to you from the hat which you are wearing right now.
Okay. Yeah. So AWS, we are a cloud solution provider, and with a comprehensive 200 plus kind of services, which range from, say, compute or databases or IoT, AI/ML, and generative AI. And these solutions are, with the right architecture, when building and running solutions on AWS, scale is something that we achieve, right? I mean, when we say our customers achieve, and there are quite a few customers who run million scale transactions kind of systems on AWS, be it in utilities or outside utilities as well. And apart from this, there are a lot of AWS partners who also build solutions using these AWS services, and again within the well-architected framework that I mentioned for specific business use cases related to utilities. It could be again smart metering or EV charging, or say renewable generation monitoring or renewable forecasting, and even in say generation. If we talk about say asset maintenance, how could you make it more AI-driven asset maintenance? So quite a few partners have solutions which can be leveraged by utilities for implementation. And third, another thing that I want to say is that there are quite a lot of reference architectures that we as solution architects within AWS we also create, which are specific to a few business scenarios. Like for example, renewable data lake is another one. So what could be the reference architecture that we can that organizations can adopt when they run solutions on AWS? Similarly, it could be around say energy storage monitoring, or it could be around say battery health analytics. So these are applicable across our power sector value chain. It could be in the distribution, or it could be in the generation domain. And there are something called AWS samples, which are also come from AWS, which could be deployed by utilities. But important point, how we relate it to IES is the scale of adoption or the rate at which they adopt is something which is needed, because obviously this would need changes in the systems that they are already running or planning to implement. So now there is a good advancement in terms of using AI to bring about speed in the development life cycle of applications or modernization that we do. So that is where as well AWS plays a good role and help organizations do that.
Thank you, Said. I think probably all the audience which they listen to, so they will definitely reach out to you separately for probably that. So, I mean, maybe I'll come to the last question for both of you. So it's a common question. So that what do you see as the single most transformative opportunity that India Energy Stack presents for the power sector? I mean, what would be your key message to this utility leadership? So most of the audience are from utilities, which we have seen today. So how to embrace this digital transformation? So what would be your single one message from, so one line from both of you, and then we'll open the floor for the question and answer session.
So should I talk now?
Yes, sir. Whoever goes first.
So yeah. Actually, if you see, the utilities are sitting very gold mine of data. And this data, because they are in siloed and they are being analytics, they are being analyzed in silo. So we are not benefiting from the collective wisdom of this data. If this data is shared, this data must be shared, because we are not able to share that data because of the very clear sharing regulations of data sharing policy. And if this data is shared on the DPI, and there are utilities and there are experts who are doing the analytics on this data. So that collective wisdom will be very, very useful, and it can transform in Indian energy sector is in a very long different way, and it will also improve the stability, profitability, everything, because when we have the data and AI which can predict so many things from the data. So again, this my single most advice to all the utilities: please share the data, and we will have a very good opportunity with the IES, and this data should be shared equitably. It is not that we are sharing to one agency, we are not sharing to other agency. So this is my takeaway.
Thank you, sir. Yeah, this is very, very good point which you mentioned. Please, you are sitting in a gold mine, but when we have seen that when you ask for any data from different sources, if you are wearing different hat, from the same offices, we have experienced receiving different sets of data. So
Now,
very good point.
one incident I would like to mention here. Forecasting software. RE forecasting software requires very older data, all demand data of last 5 years, 6 years. So that we can tune that algorithm in the RE forecasting. But data was not available to the software developer. So this type of things can be solved with this.
Yeah. Thank you. Sai, what's your message?
Yeah, sure. I mean, just to add to what P.K. Agarwal said, I mean, one is in terms of the utilities that use the data. And when we talk about IES, fostering innovation is another aspect, right? So there could be startups who would want to use this data and provide more insights to consumers as well, right? So one is from utility or the grid operation standpoint. Other is from consumer standpoint on what value added services can consumers get. Like it could be, a startup who would want to analyze their consumption and tell them what could be the energy efficient devices that they can apply, right? So that could be a simple example. Or look at their rooftop solar generation and tell them what could be the right net metering thing that they can actually plan. So that level of data exchange is something that we should probably look at in future once the IES is in place. And from utilities perspective, I think what I would say is, uh, uh, even if we come up with a lot of these things around IES framework, talking about different APIs, different business functions, unless the utilities push for adoption, we won't see the results. So that prioritization of implementing those specific IES related functions and relating it to our, basics of business priorities, like, reducing losses, SAIDI, SAFE, KPIs. So prioritizing adoption of these IES framework, aligning with our business priorities, uh, is something very important that they should be looking at, because different systems have been implemented over the past. I mean, I've been looking at this digital transformation for at least 20 odd years, and different systems came in. And what is more important is how do we align those to our business objectives.
Yeah, very good. I mean, thank you, Sai. So I think before coming in, I would definitely feel that for myself. I mean, before coming into the session, I had a little bit of a blank slate in my mind, but with this very engaging session with all three of you, I at least have something to take away. So we can open the floor from the audience for any questions, or already people have typed their questions in the chat box. We can take it from there. And Suchitra, Ronkini, if you have received any questions, so probably we can ask those questions to both Sai and Agarwal Sab right now.
Suchitra here. So there is one question from a participant for Mr. Sainath. He says that several technology service providers are working on data sharing and intelligence layers, and there are similarities with what is already, with what is envisioned under IES. So how can we make sure that the work that is done already by such startups can be leveraged in the context of IES? And how can we avoid duplication of these kind of efforts?
So,
So
Sai,
in fact,
Sai is the right person.
yeah. So in fact, what I would, that's a good point, I would say. So when we talk about the IS stack, what we should, it necessarily doesn't have to be, a one-way kind of a API development or a framework creation. What we should also allow is that, more of, if crowdsourcing could be a right word, that could be another aspect that we should be looking at, right? So because, there are a lot of startups, a lot of large developer community that we have in India, and people have innovative ideas. Say, for example, if I create a AI agent, which could probably find a different way or analyzing an asset maintenance history using, say, generative AI, right? So why should someone else again develop the same thing and include it in the IES framework? So why not me as a developer probably contributed to that network as well, right? So similar thing could apply, so that there is larger usage of different innovative ideas and implementation, obviously, by utilities. So that is one thing that we should, we should rather consider.
Yeah. I think just one question for Mr. Mediratta. So we all know that he has now moved from energy power sector to the gas sector. So his question is that if we see that similar kind of a stack in gas sector, yes, why not? I mean, my answer would be obviously yes. I mean, so it has to. So maybe Agarwal sir, we want to comment on that. We come in for that.
Yeah, because Mr. Mandiratta is connected with the gas exchange, so he's very much worried about this. So, but because once we have IES for energy sector, so gas is again is like an
Part
energy.
of energy, yeah. Gas
So
is
yeah,
part of
so
energy.
I think that can be adopted later on. That IES can be adopted with this gas also. Why gas also? Why not the petroleum? Why the other things also? I think it will be it should be designed like this, that it can be adopted with a similar energy sector. So and this question, but Sainath answered that. He answered from the perspective of the startup and the developer. But IES, when it is being developed, so they are already infrastructure where grid company are using a standard naming convention, like participants in power exchange, participants in REC. participants in NOAR, they already have a unique name, because otherwise they cannot move in anywhere on. So when we are having meeting with the IES working group, so this was the point raised, that whatever already existing, that is to be integrated the same. Otherwise we cannot disturb the already existing system which is running, which cannot be switched off or switched on. So this new IES will be absorbing all taking or integrating all the system which is already available. And again, why to reinvent wheel? So why startup is doing this? Because they will be doing for a smaller area, and IES is for whole India. I will also tell that IES will also work for the neighboring country. But it will not be a global India. It will be a global level. Because when we are connected to Bangladesh, Bhutan, or Nepal, we are also having their data in India, and then we are also sharing their data to them. So there will be a unique identifier for them also in the Indian IES system.
Yeah. Thank you. I think there's another question for you specifically, Agarwal sir, that someone is asking about the readiness of gridco in forecasting, and particularly for RTM and dam scenarios. I mean, if application layer of IES gives a lot of importance to this or not.
So basically, forecasting is now done by grid operator. Forecasting is mainly done by developers. The grid operator do the forecasting for their system security, for the grid security, and the developers do the forecasting for their scheduling, for their availability of their RE system. So grid India or grid operator, they are doing forecast mainly for demand, so that they can have a grid security studies. And REMC, which they are doing, so they are employing outside multiple forecasting provider, and then forecasting that different multiple forecasting provider is being consolidated or merged in an application, AI based application, which sees what were the error before error in forecasting, and based upon they give the weightage to different forecasters. So like this way, forecasting is done, and they are prepared. There are many software developed, and one of the software is being developed by IIT. So I think developers, even grid operators, all are ready for already ready and evolving. The forecast software evolving for them.
So there's another sensitive question for you, Sai. I mean, I'll leave it to you to answer it or not. I mean, can you read that, or I need to read that for you?
I read that. I mean, I'll limit my answer to saying that utilities are already using AWS. That's the answer that I want to limit it for now.
Yeah, and okay, then there's one more question on the P2P energy trading. I mean, how that will impact the IEX and the centralized market he's talking about. So, Agarwal sir, you want to take that, or?
P2P energy trading is mainly for the smaller generators like rooftops, DERs. So they are localized. So there is a localized market, and IEX is the bulk power market. So I think I don't think that P2P trading will have effect on the, like this is similar that we have local market and we have wholesale market in the other commodity markets. This is similar. It will be here. So I don't think it will have any effect on IEX and Taj market.
Yeah. Okay, sir. And I think the question from Victor, Sai already answered it partially earlier, but maybe you can just additionally add to it. He said how IES can ensure the data reliability and quality. So if you want to, again, both of you, Agarwal sir, you can also add to it. Okay.
Which question I
It
missed?
says that how can IES ensure data reliability and quality?
I think we are taking wrongly as IES. IES is a concept, and then it will be having a DPI, digital public infrastructure, which is for sharing the data. Reliability and quality it depends upon the source of data, where the data is generated. So quality of data depends upon the how it is measured. How it is measured from the transducer, how it is measured in the substation. And reliability is only the communication protocol and communication line. So I don't think that IES will have any effect on reliability and quality of data. Which data? I was answering the real time data, but if you commercial data, so again, if commercial data reliability is because DPI is an infrastructure and API, whatever the API reliability is there, I think this is already working with all the reservation system, all the data sharing. So the reliability will be there, but quality depends upon where data is generated.
Yes, I think IES or without IES also, these aspects are something that we have to cover anyway in terms of, say, it could be encryption mechanisms, data at rest, data in transit, or in terms of authentication methods. So these are or retry methods or failure mechanisms. So these are standard aspects which need to be considered anyway. When we talk about integration.
Okay. Suchitra, Shuddha, anything you want to take? Any other questions? So we have already overshot because we start quite late. So because we need to also.
Sorry, I was on mute. There is one Arindam that I would like to add. There are several. I try to club them all and ask. So people are asking about the effect of renewable integration on the grid and how IES can, cater to that. So even Sudha in his presentation mentioned B2G, and we've also been speaking about demand response a little bit, and how 50% up on the upper side of 40% is what renewable penetration would reach. So how would IES come in there? How would it help to ease the situation on the grid? Any final thoughts on that? To both of you actually, Mr. P.K. Agarwal and Mr. Bandikagan.
So let me answer this because DER's rooftop, all the renewals, there are two types of renewals: grid integrated renewals and distributed energy sources. Distributed energy sources generally integrate at distribution level, and they are more granular. They are highly granular, and very small quantity but large in numbers. So when they are integrated, when they are aggregated, so they can provide very good service like demand response, service of active power, service of reactive power, because IVRs, inverters can provide all type of service, reactive power, active power. So, but how this service will be integrated in the system? In the system means grid system. If they don't have unique IDs, because once they have given a service, it should also be settled. And if service and they don't have a unique ID, or they don't have this type of platform like IES, then their services and their settlement and their contract will be very difficult for managing. So this IES will provide a platform where the services of this large granular DERs can be used for the betterment of the electricity grid, for the betterment of the reliability and stability of the grid.
Sure. Yeah. Over to you, Arindam.
Yeah. I also saw two comments from Mr. Vadova and Mr. Palit, and that's very welcome to those kind of suggestions which is given, and yeah, we should definitely try to do this kind of thing, and we agree on that. And anything else, I think. Shudha, over to you. So you wanted to do something on some question you wanted to answer? Anything? So, and I was supposed to wrap up from the thing. So anything else?
Hi. Thank you, Arindam. And I think we had a very good discussion over there. And thank you, Sai. Thank you, PK sir. And thank you, Kumar sir. So she has to leave early. And I think it will end here. And it was a very interactive session. And I will hand it over to Suchitra for the vote of thanks. Sir.
Thank you, Sudha. And thanks a lot to PK Agarwal, Shri PK Agarwal ji and Mr. Sainath Bandakavi, and to all our attendees, to everyone for staying with us despite the technical issues that we initially faced, for really cooperating with us and joining on the newer link. We're really, I mean, it's really heartening, and I'm very grateful to all of you. And we've had more than 90, I mean, sometime back we had around 90 registrations, and around 80 of us stayed together, which really goes to show how much interest there is on this topic. And kudos and thanks to PK Agarwal ji and Saina ji for bringing around different perspectives. Alok ji as well, who's left a little early. But this is clearly not the end of our discussion on this. We plan to come back with specific webinars looking at different aspects, maybe utilities, RE integration, etc. And also from the on behalf of the entire Nagia group, I thank Climacore Dialogues as well, who was Ronkini from Climacore, who really put this idea into our head that let's talk about India energy stack. We need to really start talking about it, and the first task force meeting of FSI has already happened, and we need to add to this conversation. So thanks to all of you, and we will be back with more dialogue, more conversation on this. Thanks a lot, everyone. Thank you.
Thank you so much again to all of you, and we'll try to have more such sessions, because this is just the beginning, as Suchitra had mentioned. We look forward to more such sessions. We have to learn. And thank you, Saina. Thank you, Agarwal Sahab. It was
Thank
very,
you. Thank you.
also,
Thank you. Thank you, everyone.
thanks. Yeah.
Thank you.
Okay.
Thank you.
Thanks.
Thank
Bye.
you. Thanks.